All right, so today's about implicit differentiation. What we've been doing so far is explicit differentiation, meaning that y is defined as a function of x. So it's everything we've been used to learning math. Y equals x, y equals, or f of x equals. So these are called explicit functions. So now, with implicit, well, an implicit function means that the function is defined in terms of y and x. So here would be an implicit function, 3x squared plus y minus 2 equal to 0. So it doesn't say y equals or x equals, it has x and y on the same line. So this is called an explicit function. Okay. And the reason we have implicit differentiation, we can take the reason why we take implicit derivatives is sometimes it's hard to solve an equation for y. So if we can't rearrange the equation, the implicit equation, into an explicit equation and solve for y, then why not just take the derivative, the implicit derivative of the function or equation, and then solve for y after. So this is why implicit differentiation was made, to make derivatives a lot easier. So you don't have to rearrange every equation to solve for y. Okay, so that's the difference between an explicit function and an implicit function. All right. So when you are differentiating implicitly, you derive both sides with respect to x. Oops. As you see here on the first step. So we would say d over dx of 3x squared plus y minus 2 equal to d over dx of 0. So you apply the derivative to both sides. And then you will take the derivative separately of every single term, giving us 6x plus y prime equal to 0. And once you take the implicit derivative, all you have to do is solve for y prime. Okay. So that's our goal here. When we take the implicit derivative, we are going to just solve for y prime. Now, my math lab has different types of notations for the implicit derivative. So below, there's a little key that we'll go by. These are the implicit derivatives of y with respect to x. So the implicit derivative of y is y prime. The implicit derivative of y squared is 2y prime, and the implicit derivative of y cubed would be 3y squared y prime. Now I'm going to show you how these notations work. So what we're saying here is that if I said d over dx of y, so this says the derivative of x, the derivative of y with respect to x. The way my math lab is going to write it is as dy over dx. The way I like to write it, to keep our work simple, is I write y prime. So y prime just keeps the notation simple, and we don't have a bunch of messy dy dx's everywhere. And then, to go with the next one, if I said d over dx of y squared, you would have 2y dy over dx, or 2y y prime, just like I have there. And then for d over dx of y cubed, that would be 3y squared dy over dx, or 3y squared y prime. And then for any other power other than 1, 2, or 3, we would have d over dx of y to the nth power, and you'd have n times y to the n minus 1 times y prime, or dy over dx, whichever you prefer. So those are notations we're going to have. Okay, so just in case you see them, you now know what they mean. All right, so we can reference this lovely little key or legend as we work through these problems today. All right, so let's get started. Oops. Okay. So number one, we want to take the implicit derivative of 5x cubed minus 1. We want to solve it for y prime. And then after we get the implicit derivative, we're going to plug 2 and 4. Well, 2 in for x, and we're going to plug 4 in for y, depending on our implicit derivative. Okay. So let's get started. And the way I'll start this is I'll say d over dx. I apply it to both sides of 5x cubed minus y equal to d over dx of 1. Okay. And now the derivative of 5x cubed is 15x squared minus the derivative of y with respect to x is just y prime. And the derivative of 1 is 0. There's our implicit derivative. Now all we have to do here is solve for y prime. I'll just add this y prime over to the right side, and I'll get 15x squared equal to y prime. There's our derivative. And now let's go ahead and evaluate. And when you evaluate these functions, the notation looks a little funny as well. We say y prime being evaluated by the point 2, 4. So this will equal 15 times, and the only number we can actually plug in here is the x value of 2. There is no y values on this equation. There's only an x value. So you're going to get y prime equals 15 times 2 squared. And this will give me 15 times 4, or 60. And there you go. That is an implicit derivative. So any questions on that?
So you got the 2 points from the given equation, correct?
Yes, so the 2, 4 came from the original problem.
And we only use the 2?
Yes, because
on the x?
Exactly. It depends on the derivative. Let's say if my derivative ended up being 15x squared plus y, then I would plug that 4 in for y. But since there are no y's, we only have to plug in the 2.
Yeah. I got you.
Yeah. All right. Any other questions on that? All right. Let's try it again. Okay. So again, we'll start off. We'll say d over dx of y squared plus x cubed equal to d over dx of -4. Again, once we do the implicits, our goal is to solve for y prime. Okay, so the implicit derivative of y squared with respect to x, if you look above at the legend on your paper, would be 2y y prime plus the derivative of x cubed is just 3x squared equal to 0, the derivative of -4. Okay. Now, again, our goal is to solve for y prime. So move that 3x squared over and divide by 2y. And we'll get y prime is equal to -3x squared over 2y. There's our implicit derivative. And now we are going to evaluate it. We're going to say y prime at the given point of -5, 4. Again, now we actually have a y value. So this is going to be -3 times -5, the x value, over 2 times 4, the y value. And then just simplify. And you'll get negative 3 times 25. So negative 75 over 8. And I can leave it like that unless I wanted a decimal number, but I don't think you can break this down anymore.
So another quick question.
Go ahead.
I'm kind of confused. What are we actually solving for here? So what is that? Because that's, you have a y and an x. So what is 75 over 8? What is that?
So truthfully, again, this is derivative. So what would 75 over 8 represent?
So that, wouldn't that just be 0 as a derivative?
That would be the, no. So remember that,
That would be the slope at one point.
there you go. So this is the slope at this point for this implicit function.
Okay.
There you go. And again, the reason we're using implicit is so we don't have to rearrange this equation and solve for y. So implicit makes the derivative actually a lot easier because we don't have to rearrange anything. So if I were to show you that, look, so if I were to rearrange this equation for y, it would become y squared equals negative x cubed minus 4. But then I would have to solve it for y, so I would square root both sides. And you would get y equals the square root of negative x cubed minus 4. And now, in order to get y prime, we would have to take the derivative of both sides, which means this would involve chain rule. If I were to take the derivative of this, so let me just rewrite that, x cubed minus 4 to the 1/2, the derivative would be 1/2 times negative x cubed minus 4 to the negative 1/2 times negative 3x squared. Is this looking complicated already?
Yeah.
Because then next, your final answer would be negative 3x squared over 2 times negative x cubed minus 4 to the 1/2. And believe it or not, this derivative and this derivative is exactly the same. Because this piece right here is y. That's what we figured out right there, right?
Yeah.
So we can keep doing it the old school way, or we stick with implicit, where this looked way simpler than all of that, right?
Yeah, that's cool.
I like that one better.
You like the old school or the new school way?
the blue one.
The blue one. There you go. See? And again, sometimes we can't even solve for y. So that's where implicit helps us out as well. There are some equations you cannot just solve for y itself. So that's where implicit helps you out. Crazy, right? Just a simpler process to make your life easy. Okay. And yes, just like all derivatives, when you find a derivative, you're just finding the slope of a given function. And now if we're plugging in a point, we're finding the slope of the function at that given point. So negative 75 over 8 would be the slope of the original function at negative 5,4. All right. What are the questions on that? All right. And of course, this leads to something bigger. The next class will have something called related rates, where we're going to take the implicit derivative of x and y with respect to time. So this section is setting us up for that. Okay. 3. Let's do it again. So we're going to say d over dx of y squared minus y equal to d over dx of 4x. And now we use our implicit derivative key on the first page, and the implicit derivative of y squared is 2y y prime minus the implicit derivative of y, which is y prime, equal to 4. Okay, and remember, after you take the implicit derivative, your goal is to solve for y prime. So if you look at the left side, you have a greatest common factor of what?
Y prime.
Y prime. Factor out the y prime, and you're left with 2y minus 1 equal to 4. And then solve for y prime, divide by 2y minus 1, and y prime equals 4 over 2y minus 1. There it is. There's your implicit derivative. And then, of course, evaluate y prime evaluated at the point 3, 5. Is there an x value anywhere for us to plug in?
No.
Nope. So we only plug in for y. And you'll get 4 over 10 minus 1. You'll get 4 over 9. Any questions on that one? Okay. Next one. Do it again. This one's going to take a little bit of work, though. So here we're going to say d over dx of 3xy minus 2x equal to d over dx of 2. Okay. So since this is explicit, this means x and y are their own functions. So that means when we get to this term, we are going to have to do an implicit product rule. Implicit product rule. Yes. But we're only going to do it on the x and the y. That 3, we're just going to leave outside for now. So this will get an implicit product rule. Where when you set this up, f will be x, g will be y, and then derivative of x is 1. Implicit derivative of y is y prime. So your implicit product rule of xy, we'll say of xy is going to equal, and let's go ahead and make this a formula so it can probably help you out later on. If we follow this product rule, f prime g, you'll get y plus y prime x, but I like to write it better as x y prime. So save that somewhere in your notes, highlight it, whatnot. The implicit product rule of x times y is y plus xy prime, which means we can now move on with our derivative. So that 3 is out front. So you have 3 times the implicit product rule, y plus xy prime, minus the derivative of 2x, which is just 2, equal to the derivative of 2, which is 0. The derivative's done. All we have to do now is solve for y prime. So go ahead and distribute that 3. 3y plus 3xy prime minus 2 equal to 0. Now move everything over that doesn't have a prime, which means the 3y and the 2 are going over to the right side. So we'll be left with 3xy prime equal to, what's going to be? I'll say 2 minus 3y, or negative 3y plus 2. And now all you have to do is divide by 3x. And y prime equals 2 minus 3y over 3x. There is your implicit derivative. And now all we have to do is plug in 1 and 3 for x and y. Two minus 3 times 3 over 3 times 1. That's 2 minus 9. So that's negative 7 over 3. There it is. Okay. Any questions on that one?
So we do that product rule when they have a x and y next to each other.
Exactly. When they're connected by multiplication, you're going to have to product rule it. Okay. Let's keep moving. All right. Some more fun ones. All right. 5. Do it again. We'll say d over dx of x squared y minus x cubed equal to d over dx of negative 5. And once again, we have an x and y combined. So once again, this will need an implicit product rule. Okay, so this means that f will be x squared, g will be y, f prime will be 2x, and g prime will be y prime. And now just follow your product rule, 2xy plus y prime x squared, or I'm going to write it as x squared y prime. There we go. There's the implicit product rule of x squared y. Now let's continue. And that's going to come down 2xy plus x squared y prime minus the derivative of x cubed 3x squared equal to 0. Okay. There's our derivative. That's our implicit derivative. Now move everything over that doesn't have a y prime. Our job is to solve for y prime now. So x squared y prime will stay here. On the right side, I'll have positive 3x squared minus 2xy. And then just divide by x squared, and we'll have y prime equal to 3x squared minus 2xy over x squared. And now I think my math lab wants you to go one extra step to simplify this because we can. The other ones we couldn't do much. This one we actually have a common factor. If you look at the numerator, what's my common factor?
X.
I can factor an x out, and that'll leave me with 3x minus 2y over x squared. And then this x will cancel, and this power will become a 1. And we get our implicit derivative simplified at 3x minus 2y over x. So if you have a chance to simplify, then do it. The other ones we did not. And now just evaluate it. Y prime at 2, 4. Plug in 2 for your x's, and then 4 for your y's. 3 times 2 minus 2 times 4 over 2. And that'll be 6 minus 8, which is negative 2 over 2, which gives us negative 1. Okay. Any questions on that one? Okay. That means last one. The demand X is the number of items that can be sold at price P. For X equals P squared minus 4P plus 1200, find the rate of change of P with respect to X by differentiating implicitly. Okay. So all this wants us to do is find the rate of change of P. Basically, find the derivative of P prime. So what we're going to start out doing first is taking the derivative, the implicit derivative of both sides of the equation with respect to X. And then the derivative of X is 1 equal to the derivative of P squared. It's just going to be like Y, just replace Y with P. So the implicit derivative of P squared is going to be 2P P prime minus the derivative, the implicit derivative of 4P is 4P prime. And then, of course, the derivative of 1200 is 0. So now all we have to do is solve for P prime, which means on the right side of this equation, P prime is our greatest common factor. So you'll get 1 equals factor out of P prime, and you'll get 2P minus 4. And then divide by 2P minus 4. And we are finished. This formula, this equation, gives us the derivative of P, or the rate of change of P with respect to X. And that is implicit differentiation, guys. So if you got any questions, ask. Other than that, we're done.
Easy.